Welcome, great student, to new video on organic chemistry. That means the study of hydrocarbon compounds and its derivative, organic chemistry. In today's video, we shall discuss the chemistry of alkane, the chemistry of alkane, which is known as saturated hydrocarbon. We shall look at the meaning of alkane, the first member of alkane, which is methane, and we shall discuss the preparation of methane, the preparation of this homological series according to what JAM scheme of work, because JAM scheme of work only asks for certain preparation of alkane. We are not going to go beyond JAM scheme of work for this. We are going to look at JAM scheme of work for preparation. We are going to look at what chemical properties of what alkane, physical properties, and what affect the boiling point and melting point of alkane. Then we look at the uses of what alkane. Let us start. Alkane. I told you alkane is also known as what paraffin. 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 Alkane is also known as what paraffin. This this homologous series has a general formula that is known as CnH2n plus 2. This is the general formula of alkane, CnH2n plus 2. That's the general formula of alkane. And to get the first member of alkane, when n equal to 1, you get the first member, which is C1, then 2 times 1, 2 plus 2, 4, which is known as what? Methane. That's what the first member of this homologous series, alkane, which is also known as what? Paraffin. This is methane. To get the second member, when n equal to 2, you have what? C, when n equal to 2, H, 2 times 2, 4 plus 2, 6, which is what? Ethane. To get the third member, when n equal to what? 3, you have C3H, 2 times 3, 6 plus 2, 8, which is what? Propane. Then from here, you can get the fourth member, the fifth member, the fourth member, which I will stop on, Cn, that is C4H, 2 times 4, 8 plus 2, 10, which is what? Butane. And don't forget, I told you under alkane, the branches, isomer, start from what? From butane. Isomerism start from what? Butane. That means branches start from what? Butane. Take note of that. Under alkane, alkane isomerism or isomer start from what? Butane. Under what? Alkane. Take note of that. This alkane, I told you they exhibit single bond. There is single bond between its carbon-carbon atom. It exhibits single bond between its carbon-carbon atom. Why? Because it exhibits a sigma bond electron. Sigma bond electron. Sigma bond electron. It exhibits a single bond. I told you single bond between its carbon-carbon atom. Single bond between its carbon-carbon atom. And it exhibits sigma bond electron. Sigma bond. It exhibits sigma bond. Take note of that. And this alkane has hybridization of sp3. Hybridization of sp3. Alkane has hybridization of sp3. What is an hybridization? Let me quickly give you the meaning of hybridization. The hybridization of alkane is sp3. sp3. Take note of that. What is the meaning of hybridization? Hybridization, this is the intermixing of atomic orbital. We have hybridization. Hybridization. This is the intermixing or mixing of atomic orbital. Atomic orbital of an atom. Of atomic orbitals of an atom having slight difference in energy to form new sets of orbitals. To form new set of orbitals having the same energy and shape. Take note. That is what hybridization. Hybridization simply means the mixing of atomic orbital of an atom having slight difference in energy to form new set of orbital with the same let me put with the same energy and shape. With the same energy and shape. And I told you hybridization of what alkane of carbon atom of alkane is sp3. The hybridization of carbon atom of alkane rather, the hybridization of carbon atom of alkane is sp3. What do they mean? When you have, look at this, we have carbon. The atomic number of carbon is 6. What is electronic configuration of carbon? We have 1s2, 2s2, 2p2. This is what the electronic configuration of carbon. The electronic configuration of carbon. And we have this. The first S is filled with what? 2 electrons. Don't forget, S of shell can take maximum of what? 2 electrons. And the first energy level that has what? S of shell has been filled with what? 2 electrons. Then look at the second and what? The second S and what? The second P. Don't forget, the second S we have, when you have something like this, the second S, don't forget, S sub shell has what? 1 orbital. And inside that 1 orbital, we have 2 what? Electrons. Then we have what? P. That means 2p. This is 2p. 2p. P sub shell has 3 what? Orbital. Take note. P sub shell has 3 orbital. And in this P, how many electrons are there? 2. That means we have this. We have this. We have this. This is the ground state of our carbon atom. Then in the excited state, for this carbon atom, for the orbitals in carbon atom to exhibit what? To undergo hybridization. This 1 electron, the 1 electron from the 2s subshell, from the 2s orbital, 1 electron from what? The s orbital in the second energy level will migrate to this point. This is what? 2ps. This is what? 2py. This is what? 2pz. Then 1 electron from here will migrate to this what? To this point, in which how many electrons will be here? 1. Then in this case, this one will now combine, this 1s will combine with this one, how many p? 3p. The first p is what? ps, py, pz. 1s will combine with what? This 3p. Since 1s is combining with how many p? 3p. The hybridization of what? Carbon atom of what? Of alkane is what? sp3. Why? Because this s in the second energy level is mixing with these 3 orbitals of what? 2p. 3 orbital. 1 orbital in what? 2s is mixing with what? 3 orbital of what? This 2p. Since they are mixing together, that means we have 1s mixing with what? 3 orbital of what? Of 2p. That is hybridization of alkane. That means hybridization of alkane is what? sp3. Take note. sp3. Hybridization of alkane is what? sp3. And the bond angle, let me give you, when you have this, this is, don't forget, let me rub up this. Let me rub up this. That means you have the first ps, we have py, you have PZ, that means, then one S is mixing. We have this. Then this is what? The carbon of what? Carbon of what? Of alkane. Then we have, don't forget, in alkane, how many hydrogen do we have? 4. Each hydrogen is attaching itself to this. We have one hydrogen here. We have one hydrogen here. We have one hydrogen here. In this case, this is what? The structure of what? Alkane, methane. The hybridization of a carbon atom of methane is what? sp3. Take note. And the bond angle of what? Methane. The bond angle of methane is what? 109 degree. Take note. The bond angle of what? Methane, that is the bond angle of alkane, is 109 degree. The hybridization is what? sp3. That means one s orbital from the what? Second energy level is mixing with what? 3p orbital from second energy level. 3p orbital. This is 3, one first, second orbital, third orbital. That means p subshell has how many orbital? 3. This is the first orbital, second orbital, third orbital. P subshell has 3 orbital. The first orbital, second orbital, third orbital. One electron from the ground state of carbon atom then move to the what? Excited state. In excited state, join the what? The vacant that is here. Therefore, this orbital from the what? 2s of shell is mixing with what? These 3 orbital from what? 2p subshell. That is sp3, hybridization of alkane. Let us move further, please. Let us move further. I told you, alkane has general formula CnH2n plus 2. It has hybridization of sp3. It has bond angle of what? 109 degree. And I told you that the first member is known as what? Methane. The first member is known as methane. And methane can also be called marsh gas. Why? Because it can be found in marshy area or swampy area. It can be found in swampy what? Area. It is the first member of what? Methane is known as what? Marsh gas. It can be found in what? Marshy or swampy area. Take note of that. And this methane, which is the first member of alkane, is the major. Methane is the major component. This question came out in German. Why? Is the major component of natural gas. Natural gas is the major component of natural gas. If they ask you which of the following alkane is the major component of natural gas, yes, the answer to that question is what? Methane, major component of natural gas. And methane is explosive in nature. Methane is explosive in nature. 5% to 14% of methane in air can cause explosion during mining. 5% to 14% of methane in air can cause explosion during what? Mining. Take note of that. Take note of that. Please take note of that. Please let us move further. Let us look at the shape of methane. That is the shape of alkane, of methane. The shape of methane is tetrahedral. Tetrahedral. That means the shape of methane is the same thing as what? Geometry. Geometry of methane. Take note. The shape of methane, which is tetrahedral, is the same thing as what? Geometry of what? Methane. Why are they the same? Take note of this. Take note of this. Whenever you have a central atom without any lone pair of electron, whenever you have a central atom, which one is the central atom here? Carbon. Carbon is the central atom. Whenever you have a central atom with no lone pair of electron in which there is no lone pair of electron. No lone pair of electron. Shape will be the same thing as our geometry. Take note. I will do a video on hybridization proper, in which I will explain that. Whenever you have central atom with no lone pair of electron, in this case, there's no lone pair of electron. We only have what shared pair electron, shared pair. And how many shared pair? 1, 2, 3, 4. That means we have 4 shared pairs of electron. That means hydrogen and carbon, they are sharing what? Electron. Hydrogen and carbon sharing electron, hydrogen and carbon sharing electron, hydrogen and carbon sharing of electron. There's 4 shared pair electron in which there's no lone pair of electron. Geometry will be equal to what? Shape. That is why the shape of what? Of methane is tetrahedral. Why? Because the geometry is also what? Tetrahedral. The shape of methane is tetrahedral. Why? Because the geometry is what? Tetrahedral. And shape is equal to geometry if there's no lone pair of electron. Look at this. Look at water, for example. This is water. Water has what? Lone pair of electron. This is one lone pair. This is another lone pair. That means in this case, shape and geometry can never be the same. Yes, this is one lone pair. This is another what? Lone pair. That means this one has the central atom has lone pair of electron. Therefore, shape and geometry can never be the same. Take note of that. That is why the geometry of water is tetrahedral. Geometry. Take note. Geometry of water is what? Tetrahedral. Hybridization of water is what? sp3. Then the shape of water. The shape of water is what? V shape or bent shape. Geometry is tetrahedral for water. Shape is what? V shape or bent. The geometry and shape are not the same because it has lone pair of electron. But look at carbon in methane. It has no lone pair of electron. That's why the shape is what? The same thing as geometry. Geometry is tetrahedral. Therefore, shape is also what? Tetrahedral. But in water that has the central atom has one lone pair of electron, the shape is not what? Tetrahedral. But the geometry is tetrahedral. And the hybridization of water is sp3. Hybridization as a topic, I will let you know better. Let's move forward. And what have you learned in this? I told you that I've given you what? The shape of methane, that means alkane, as well, tetrahedral. I've given you that the bond angle of alkane, methane, is 109 degrees. I've given to you that the shape and the first member, which is methane, can be called what? Marsh gas. And this carbon to hydrogen in alkane exhibit was sigma bond. Sigma bond means what? Single bond. When you see single bond, that means sigma bond. When we get to hybridization, I will explain better. It exhibits what? Sigma bond electron. Sigma bond. Alkane exhibits sigma bond electron. And I told you that methane is also known as what? Marsh gas. Let's move forward. And the major constituent or component of natural gas is methane. Let us move forward. Let us move to preparation of alkane. Let us take the first member, methane. Let's take the first member, methane. According to your scheme of work, we have several ways of preparing methane, alkane. We have several ways. We have hydrogenation of unsaturated hydrocarbon. We have what? Using what? Cubic electrolysis process. We have what? Reduction of what? Alkyl halide. We have so many ways. We have cracking of higher what? Alkane. We have so many ways, but according to your scheme of work, we have to look at what? Cracking. We have to look at what? Decarboxylation reaction. which is very important. This one is very important. The carboxylation what reaction. Then we have to look at what reaction between aluminium carbide, aluminium carbide with water, with water. These are what your scheme of work asks you to know according to JAM. Let's take the first one, cracking. I told you cracking is a conversion process. Cracking is the breaking down of large hydrocarbon compound into a smaller hydrocarbon compound. Another name for cracking is what? Pyrolysis. Pyrolysis. Take note. Pyrolysis. Pyrolysis. That is cracking. Another name, breaking of higher hydrocarbon compound. Just hydrocarbon compound. Compound that contain carbon and hydrogen into smaller ones. Take note of that. Let's look at cracking. When you have cracking of higher alkane, cracking of higher alkane, cracking of higher alkane, it will give you smaller alkane, which is saturated. I told you alkane is what? Saturated because of what? Sigma bond electron, which what is single bond. It is saturated. Alkane is saturated because of sigma bond electron, which means what? The single bond between the carbon atom. Cracking of higher alkane will give you a smaller alkane and unsaturated compound, which is what? Alkene. Take note of that. Take note. When higher alkane undergo cracking, pyrolysis, smaller alkane will be given, which is saturated, and one unsaturated will be given, which is what? Alkene, unsaturated. And alkyne can also be given, highly unsaturated. Alkyne can also be given. Let us go to the second one. The second one, reaction between aluminium carbide and water. Aluminium carbide and water. That is another process in which alkane can be prepared, and we are looking at what? Methane. For example, when you have aluminium carbide plus H2O, water, what will be formed is what? Aluminium hydroxide plus methane. This is methane, which is a gas. Let me balance the equation. Put 12 here, put 4 here, put 12, put 3 here, 3, 4, 12, what times 12. This is what? Reaction between aluminium carbide and what? Water to give aluminium hydroxide and what? Methane. This is another reaction of what? That can be used to prepare alkane, that is methane. Methane. Reaction between aluminium carbide and water to give what? Aluminium hydroxide and what? Methane. Let us move further. The one that is very important, the carboxylation reaction. Very important. The carboxylation reaction. The carboxylation reaction. When you have RCOONA plus sodium hydroxide from soda lime. This is soda lime. Sodium hydroxide from soda lime. What will be given? You have RH plus Na2CO3. Take note of that. This one is for sodium alkanoate. Don't forget what is general formula or the general formula of alkanoate. That means you are of alkanoic acid. RCOOH, alkanoic acid. This is alkanoic acid. Then when this hydrogen is replaced by a metal, we have sodium alkanoate. Sodium alkanoate. This is sodium alkanoate reacting with what? Sodium hydroxide from soda lime. Don't forget, we have soda lime. Soda lime is used in preparation of what? Alkane from sodium alkanoate. Take note, let me quickly write it down. Sodium, soda lime is used in the preparation of alkane from preparation of alkane from sodium alkanoate. And take note, soda lime, is it okay like this? Soda lime is a mixture of quicklime and what? Sodium hydroxide. Take note, soda lime is a mixture of what? Calcium oxide and what? Sodium hydroxide. Take note, soda lime is a mixture of calcium oxide and what? Sodium hydroxide. It's a mixture of calcium oxide and what? Sodium hydroxide. And this sodium hydroxide is a caustic soda. There's a question in JAM. The JAM question says, why do we prefer soda lime in preparation of alkane to what? Caustic soda? The reason is that soda lime, this one, soda lime, if you use soda lime directly, it attacks glass and it is a deliquescent substance. But if the soda lime is used, which contain little amount of sodium hydroxide, that sodium hydroxide cannot attack glass. That means soda lime does not attack glass and it's not a deliquescent substance. Take note. Have you written this? Just like this, let me explain. That means soda lime is used in preparation of alkane from sodium alkanoate. And soda lime is a mixture of what? Two things: calcium oxide, which is quicklime, and what? Sodium hydroxide, which is what? Caustic what? Soda. Take note of that. Let me quickly. Why do we use soda lime instead of caustic soda? This caustic soda, we don't use this directly. We don't use this caustic soda directly. It should be caustic soda. It should be what? The one from what? Soda lime. The reason why we don't use this one directly is because it is a deliquescent substance. And it attacks glass. It attacks what? Glass. It attacks glass and it is a what? Deliquescent substance. Therefore, soda lime is used instead of what? Caustic soda. But the caustic soda that will be used to be what? The small portion from what? From soda lime. That means soda lime contains calcium oxide and what? CaO. That means the sodium hydroxide that must be used must be a mixture of what? Calcium oxide. You can't use this directly because it attacks glass and it is a what? Deliquescent substance. That is why we use soda lime that contain calcium oxide and sodium hydroxide. You don't use this one directly because it attacks glass and it is a deliquescent substance. We use soda lime that has what? Small portion of what? Sodium hydroxide and what? Quicklime, calcium oxide. Take note of that. Then how do we prepare that? This is the decarbonization reaction. When you have, for example, when you have CH3, COONA, this is sodium ethanoate. When you have sodium ethanoate reacting with what? Soda lime using sodium hydroxide. reacting with soda lime. What will happen? From what I've written down, this H, this is CH3, which is alkyl group. Alkyl group, CH3, alkyl group. This one represents the R. Then this H combined with the R to form RH. This H will combine with what? This R, CH3, to form CH4, which is methane. Then Na and Na will combine. That means we have 2 Na, Na2. Then COO plus another O to form CO3. This is washing soda. Washing soda. Washing soda. Sodium triisocarbonate 4. Washing soda. This is preparation of methane. How do I prepare methane? I use sodium ethanoate. If I told you homologous series, they have the same method of preparation. If you want to prepare ethane, are we going to do that? Ethane, using the same process. That means I prepare methane from where sodium ethanoate. After eth is pro. Ethanoate to get what? Methane. Sodium ethanoate to get methane. I want to prepare ethane now. I will use sodium propanoate. Sodium propanoate to get ethane. If I want to get propane, I will use sodium butanoate. Sodium butanoate to get what? Propane. If I want to get butane, I will use sodium what? Pentanoate. Okay, look at it. This is sodium ethanoate. I get methane. I want to prepare ethane now. Ethane. That's what I want to prepare. This is sodium ethanoate. I will now use sodium what? Propanoate. How will I get the chemical formula of sodium? Let us look at preparation of ethane. I told you the same method. This is sodium ethanoate to prepare methane. If I want to prepare ethane now, I will use sodium propanoate. How can you get sodium propanoate? Homologous CH2. Just add CH2 to this. Add CH2 to CH3 and we have C2H5 COONA. This is sodium propanoate plus the same sodium hydroxide from soda lime. Sodium hydroxide from soda lime. Then CaO. Then what will happen? This H we attach itself to what? This R. This is R, which is ethyl. Ethyl. This H attach itself to this to form C2H6, which is ethane. Then plus washing soda. The equation is balanced. If I want to prepare the next one, this is the carboxylation reaction to get what? Alkane. If I want to prepare propane now, I want to prepare propane. After pro is what? Brute. That means I will use sodium butanoate. For you to get sodium butanoate, just add what? CH2 to this. That means I will add CH2. This CH2, add it to this. I will have C3H7. C3H7. I have to prepare what? Propane. I'm using what? Sodium what? Butanoate. Don't forget. I have to prepare propane using sodium butanoate. I prepare ethane using sodium propanoate. I have to prepare propane now. Propane. I'm using sodium butanoate, which is CH2 to this. CH2 is H7 COONA. This is sodium butanoate plus sodium hydroxide from soda lime. What you have H plus this one will give you what? This H plus C3H8, which is what? Propane plus washing soda. If you want to prepare the next one, then you can try others on your own. I want to prepare butane. I will use what? Sodium what? Sodium pentanoate. Sodium pentanoate. I want to prepare butane. Sodium pentanoate. Just add CH2 to this. You have C for H9 plus COONA plus sodium hydroxide from soda lime. Now soda lime is a mixture of these two. Then what will happen? This H combined with this will form C4H10, which is butane plus washing soda. You can prepare pentane. What will you use? You will use sodium hexanoate. If you want to prepare enzane, you will use sodium ethanoate. If you want to prepare ethane, you will use sodium octanoate. Take note of that. That is your preparation, the carboxylation process. That is it. Let us go to chemical physical properties. Physical properties of alkane. Physical properties of alkane. Physical properties of alkane. Number one, because it is what? Hydrocarbon compound. They are what? Insoluble in water. That's why after their preparation, they are collected over water. They are collected over water. After the preparation of methane, which is a gas, it is collected over water. Because they are insoluble in water, in polar solvent. They are insoluble in water because insoluble in water. They are insoluble. Let me put it like that. They are insoluble in water. Alkane are insoluble in water. They can only be dissolved in non-polar solvent. They can only be dissolved in non-polar. They can only be dissolved in non-polar solvent, such as benzene, such as for trichloromethane. They can only be dissolved in these, just such as benzene, trichloromethane. But in water, they are insoluble. In water, they are insoluble. Number two, they have low melting and boiling point. They have low melting and boiling point. Low melting and boiling point. Low melting and boiling point. They are neutral on litmus paper. Neutral on litmus paper. They are neutral on what? Litmus paper. Let me quickly explain this. Very important. The factors that affect low boiling point and melting point of alkane. Look at alkane. Please, I want you to look at this. This general formula CnH2n plus 2. I told you this is the general formula. The first member is methane, CH4. When n equal to 1, you have methane. The second member, when n equal to 2, C2H what? C2H what? 6. And when n equal to 3, you have C3, H what? 8. This one is ethane. This one is for propane. We have n equal to 4, C4, H10. This one is butane. When n equal to 5, you have C5, H12. This one is for pentane. And I'll stop here. When n equal to 6, C6, H14. Using the general formula, n equal to 6, H 2 times 6, 12 plus 2, 14, which is ethane. Ethane. Take note, as you are coming down the group, their boiling and melting point increases. You do come out in your JAMB, in WAEC, in JUPEB. As you are coming down, the boiling point and melting point increases. Why? Because the molecular mass increases. As you are coming down, the molecular mass increases. And as the molecular mass increases, boiling and melting point increases. Boiling and melting point increases. What is the molecular mass of methane? Carbon is 12. Hydrogen is 1. Methane, that is 12. Hydrogen 1 times 4. Methane is what? 16. Yes, 16 grams per mole. Look at this one. That is carbon is 12. 12 times 2. 24 plus 1 times 6 plus 24. This is 30 grams per mole. This one, 12 times 3, 36. 36. 36 plus 8, that means 44. This one, 12 times 3, 36. 1 times 8, 8. Then 44. 44 grams per mole. As you are coming down, let's see, their molecular mass is increasing. Therefore, their melting and boiling point also increases. Option A, pentane. B, butane. C, ethane. D, methane. Which one of them has the highest boiling point or melting point? The answer is what? Ethane. Take note because it's the higher one. It has the higher molecular mass among four of them. Take note of that. Another thing that also affect their melting and boiling point. Take note. Number of branches affect their melting and boiling point. When you have alkane with branch, it will have what? Lower melting point than what? Long chain aliphatic. Look at this. This is ethane. CH3, CH2, 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 1, 2, 3, 4, 5, CH3. This is long chain. Then when you now have the branch of this, CH3, CH2, CH, I'm sorry. When you have CH3, CH, CH3, CH2, 1, 2, 3, 4, 5. Can you see? This one is for 2 methyl 1, 2, 3, 4, 5 pentane. 2 methyl pentane. This one, they have the same molecular mass, but this one is long chain, this one is branch. Because this one has branch, the branch will lower its what? Its melting point. Between these two, the one that has the highest for melting and boiling point is for long chain. When you see aliphatic with branch, it will have low melting and boiling point. It will have low melting and boiling point. Long chain has what? Higher melting and boiling point than what? Branch chain aliphatic, than branch chain what? Hydrocarbon compound. Take note of that. Please take note of that. Look at this. This one, if now two, maybe you have another branch here now. This branch, let me bring that. You have two dimethyl butane. Now, let me assume between ethane, 2 methyl pentane, 2 is this, 2 is this, 2 is this, 2 is this. You have CH3 here, you have CH3 here, you have CH2, CH3, CH3. Which one has the highest boiling point? This. Followed by what? This. This one has the lowest. This one has the lowest boiling point. This one has how many branches? 2. Take note of that. Then another thing you have to know is this. Another thing. Take note. Please take note. Cycloalkane has higher boiling point than what? Long chain alkane. Aliphatic. The long chain alkane has higher boiling point than what? Branched alkane. Let me put it like that. When you have, for example, look at this. This one, cyclo. This is cyclohexane. This one and what? Normal hexane and normal CH3, CH2, 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 1, 2, 3, 4, CH2, CH3. Then you have this. This is normal hexane. This one is cyclohexane. This normal hexane. Now have this one. I'm sorry. Now this one. Now CH3, CH2, CH2, 1, 2, 3, 4, 5. This is for 2 methyl 1, 2, 3, 4, 5 pentane. This one is cyclo. It has higher boiling point than this. Higher boiling or melting point than this. This one has higher boiling or melting point than branch. Take note of that. Please, let us quickly go to the word chemical properties. Then we call it a day on alkane. Then in the next video, we shall look at what the nomenclature and the word isomers of what alkane. Please, because of time. Chemical properties of alkane. Chemical properties of alkane. Chemical properties of alkane. Chemical properties. Chemical properties. Properties. Yes. Chemical properties. Number one. Incineration. Take note. That is another name for combustion reaction. Combustion reaction. Incineration reaction. Combustion reaction. Take note. They can ask you, as they ask, what is another name for cracking? Pyrolysis. Another name for combustion reaction is incineration reaction. And take note, this is burning of a substance in air in the presence of what? Oxygen gas. Take note of this. Whenever hydrocarbon, all hydrocarbon, take note, very, very important. All hydrocarbons, whenever all hydrocarbons undergo what? Incineration reaction, combustion reaction, in excess supply of oxygen, in excess supply of what? Oxygen, in excess supply of oxygen, the product is what? CO2 and water. The product is what? CO2 and water, carbon dioxide and water. When hydrocarbon compound that contain carbon and hydrogen, all of them, all hydrocarbon compound, alkane, alkene, alkyne, aromatic benzene, whenever they undergo what? Cycloalkane, any one of them, whenever they undergo what? Combustion reaction, in the excess supply of oxygen, the product is what? CO2 and water. CO2 and water. This is what I mean. When you have methane plus oxygen gas, excess supply, what do you have? You have CO2 plus H2O, water. This one is gas, liquid. Balance the equation. We have M input, put here. For carbon is 1, oxygen is 1, 2, put here. This is excess supply, excess of air. But when you have CH4 plus O2, limited supply of air, you have carbon monoxide, carbon 2 oxide plus what? H2O. Carbon monoxide plus H2O. Put here. That one is what? Put here. This one is 3. This one is 2, 4, 1. This one is 3 over 2. 3 over 2. Then multiply. This one is 2. This one is 3. 2. Then this one will be 4. And it's 3. It's balanced like this. So I don't want to balance with fraction. That means 2, carbon 2, 8, 6, 2, 6. Balance. Limited of oxygen, of air, limited of air. Then, but when you have methane, in very, very limited of air, very, very limited, that means the air is very, very limited. Very, very limited. Very, very limited supply of air. Very, very limited. Is it okay like this? Very, very limited of air. That means this one will give you carbon plus H2O. Carbon plus H2O. Carbon plus what? H2O. That's what this one will give you. Carbon plus H2O. Balance equation, put 2 here for that is true. The equation is balanced. Take note of that. That is combustion reaction. Let us go to the last reaction, which is what? Substitution reaction. That substitution is peculiar to what? Alkane. The only reaction they can go through is what? That they can only go is what? Substitution reaction. Number 2, substitution reaction. Substitution reaction. Substitution reaction. Whew. Yes, that is great. Substitution reaction. This is better for you to learn the concept, for you to understand all these things. Go to the first video, our first video on what? On hydrocarbon compounds. Then take it like that. You will see that hydrocarbon compound is very easy. According to JAM and WAEC, please, that's what we are giving to you. We have video coming up for what to peg A level. A level, we have that coming up. That one will be different from this. That one is what a little bit complex, but we are working with what scheme of work of JAM. Please take note of that. Number 2, substitution reaction. Substitution reaction. What is substitution? This is direct displacement of an atom or a group by another atom or a group. This is a direct displacement of an atom or a group by another atom or a group. This direct displacement of an atom or a group of radicals by another atom or a group of radicals. That's what I mean. Group of radicals. That's what I mean. Direct displacement of an atom or a group of radicals by another atom or a group of radicals. Radical. You can put it there. This direct displacement of an atom or a group of radicals by another atom or a group of radicals. This is a reaction that is what peculiar to what? To alkane, that means saturated hydrocarbon compound with sigma bond electron. I told you single bond means sigma bond. Sigma bond. Sigma bond is a topic when we get to what? Hybridization. Sigma bond is what? The combination of what? Head to head. When you have orbital connecting with what? The head to head what? Mixing. Why what? Pi bond is what? Side to side. Side to side. When I get there, I will explain, because I can, in JAM, they won't ask you for what? The core explanation of that. They will just ask what kind of hybridization in alkane is sp3. And I've given you the meaning of hybridization. And it exhibits was sigma bond electron, which is what? Single bond, sigma bond, single. That's functional group. Single bond between this carbon-carbon atom, sigma bond electron. Okay, substitution reaction. Then under the substitution reaction, we have halogenation. Example, halogenation. That is reaction between alkane and halogen family. But mostly in your scheme of work, they ask for chlorination reaction. Let me put that. Chlorination reaction. Don't let me talk on halogenation reaction. Halogenation reaction is when alkane reacts with halogen family. But I'm taking one of the halogen family, which is what? Chlorine. Reaction between chlorine and what? And alkane is an example of substitution reaction. Let me take chlorination reaction. Chlorination reaction is an example. Take note. Is there your campus question and by It's an example of what? Substitution reaction. It is an example. Of substitution. Substitution reaction. Chlorination is an example of substitution reaction. What is chlorination? That is reaction between alkane and chlorine gas. Take note. Chlorine gas in the presence of UV sunlight, in the presence of ultraviolet light, in the presence of sunlight, ultraviolet sunlight, in the presence of sunlight, ultraviolet light. Take note of that. In JAM, they won't ask you for 3 stages involved in what? Chlorination reaction. But when you get to advanced Jupiter class, the video that is coming up, I explained that there are 3 stages involved here. 3 stages. We have initiation stage, initiation state. I'm sorry for the spelling. Initiation state. We have propagation state, propagation stage, and we have termination stage, termination stage, termination stage. We have initiation state, we have initiation state, propagation stage, and termination state. Initiation state, these are the 3 stages involved in chlorination reaction. Initiation state is when what? The chlorine atom splits into 2. They split into 2. When they split into 2 with the loss of electron. This one, when the what? The alkane loses electron to become radical. This one, when the chlorine radical and the alkane radical combine together, that's it. When the chlorine gas split into 2, alkane, when the what? Alkane group, alkane also loses hydrogen atom to form radical. This one, when the chlorine gas split into 2 to form radical, when the alkane loses hydrogen atom to form what? Radical, hydrocarbon radical, which is alkyl. Then when the 2 radicals combine together, that is the 3rd stage. Chlorine gas split into 2 to form radical. Alkane loses 1 atom of hydrogen to form radical. Then this one, when the 2 radicals mix together to form the final product. But in JAM, you don't need that. Let me quickly write the reaction required in JAM for chlorination reaction, the way it is required in JAM. When you have CH4 plus Cl2, that means this one is split, they form radical. One of them, this one loses 1 atom of hydrogen. How many atoms will be left? 3. Then this one and this one combine. That's what termination process. We have a CH3Cl. Then the hydrogen loss will combine with this second one to form ACl. This one is for chloromethane. Take this one in the presence of UV. That means we have CH3Cl plus Cl2. The same process, Cl. This one loses 1 atom of hydrogen. How many hydrogen will be left? 2. Then this one combined, you have Cl2 plus. Then the 1 hydrogen lost will combine with this. It loses 1 atom of hydrogen. 2 atoms. Then this one combined with this one, Cl2. Then this one, the 1 hydrogen lost combined with this one to form ACl. This one is dichloromethane. Take that again. We have CH2, Cl2 plus Cl2. Another one. This one will come here, replace 1 atom of hydrogen again. What will you have? CH3Cl3 plus ACl. This one is trichloromethane. Another name for this is chloroform. Chloroform. Take note of that. Chloroform. Then the final one is this. The final one. Take this one again. That means final one, CH3Cl3 plus Cl2 to form CCl4 plus ACl. This one is what? Tetrachloromethane. Take note of that. It's just like this. Methane is CH4 in simple way. without initiation, propagation, termination. Please, I don't, JAMB does not ask for that. That's why I didn't explain. Just know that those are the three stages. They have three stages involved in chlorination of alkane. Initiation, the first stage. Propagation, the second stage. Then termination, the third stage. Then for Jupiter, I explained everything in Jupiter. Please. That is we have seen we have 4 hydrogen. This one means replace one hydrogen with Cl. What we have CH3Cl. That's this one. Then the second one, replace another hydrogen with Cl. Replace what we have. How many H now? 2. CH2. How many Cl? Cl2. The third one, replace another hydrogen with Cl. How many H? 1. How many Cl? 3. The fourth one, this one, replace the last hydrogen with Cl. What do you have? C. Then how many Cl? 4. That's that. The final substitution, the final chlorination, the reaction, the final chlorination of methane, methane. The final chlorination of methane is what tetrachloromethane. Take note, they can be used as what? Industrial solvent. This one, industrial solvent. Mostly, all of them can be used as solvent. Chloromethane, dichloromethane, trichloromethane, tetrachloromethane can be used as solvent, but most importantly, this one is used as what? Industrial solvent. This one, trichloromethane, which is chloroform, it can be used as an anesthetic during surgical operation. This one, chloroform, CH3, chloroform, trichloromethane. It can be used as an anesthetic during surgical operation. It's a JAMB question. It will come out. Anesthetic during what? Surgical operation. And take note, another use of what? Methane is that it can be used as fuel. Fuel is a major component of what? Natural gas. And it can be used in production of other compound. Take note, trichloromethane can be used as an anesthetic during surgical operation, and it's a good word, organic solvent. Tetrachloromethane is a good word, organic solvent. Thank you. Before I call it a day on this video, please press the subscribe button. Please comment and share to your friend and let them know about the good work. Thank you.